Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're gonna learn about flash separation for benzene and n-Hexane by group 14. So our group have three members, which is me, myself, Ashraf Hakimi, Taki Farhan, and also Dewi Alia. So what is a flash separator? Flash separator, often called as a flash drum, is a pressure vessel used to separate a liquid vapor mixture. When a high pressure liquid stream undergoes a reduction in pressure, like passing through a valve, part of it flashes into vapor. The vessel then allows the gravity-driven separation of the vapor from the remaining liquid. So this is the physical properties for our two substances, which is benzene and n-Hexane. And the boiling point for benzene is 80.1, while the boiling point for n-Hexane is 68.7. So this is the assumptions, where first, it is in steady state and adiabatic. The process parameters, temperature, pressure and flow rates do not change over time. Also, flash separator is perfectly insulated and no heat is exchanged between the system and its surrounding, which means that Q is equal to 0. Second, it is in ideal solution behavior. So, we assume that the system behaves as an ideal solution, and this allows us to utilize the Rolle's law and also to determine the phase composition without the need for complex activity coefficients. And lastly, it is equimolar feed for benzene and n-Hexane mixture. We assume an overall composition of 0.5 for each component, which is 50% for benzene and 50% for n-Hexane.
So now let's move on to the flash calculation. For the assumption, we make two assumptions. The first one is the mixture is an ideal solution as stated in the equation. Next is we assume no heat is exchanged between the system and the surrounding, which is Q equal to 0. Then for the condition of the feed, we choose temperature at 70 degrees Celsius, which is between the boiling point of n-Hexane and also benzene. For the operating pressure, we choose 103 kPa. For the flow rate, we choose 100 kmol per hour. And lastly, for the mole fraction of benzene and n-Hexane is 0.5 mole. The boiling point of benzene is 80.1 degrees Celsius, while for n-Hexane is 68.7 degrees Celsius. So that's why we choose the temperature of operating is at 75 degrees Celsius. Then, in order to find the saturated pressure of benzene and n-Hexane, we need to use n-Hexane. So, in order to use n-Hexane, we need to know the value of A, B, and C for both of the substances. After that, we substitute the value of A, B, and C and also the temperature that we choose, which is 75 degrees Celsius, into the entire equation. Then we can get the value of pressure in kilopascal. For example, the saturated pressure for n-Hexane is 122.977 kilopascal. To get the value of bar, we just divide by 100 only. Next, for the bubble point, in order to find the value of bubble point, we just need to substitute the mole fraction and also the saturated pressure into the column formulas, and then we can get the value of it, which is 104.8 kilopascal, and same goes to the U point. Then we can get the value of it, which is 101.66 kilopascal. After that, we choose the operating pressure, which is between the bubble point and also the dew point, which is we choose 102 kilopascal. For the K values, just substitute the saturated pressure and divide with operating pressure. Then we can get the value of it for benzene and also n-Hexane. After that, to find the liquid phase mole fraction, just substitute the desired values into the formula, and we can get the value of it for the benzene and also n-Hexane. And lastly, for the vapor mole fraction, just mole fraction as with the K value, then we can get value of it for the benzene and also for the Hexane. Next, to find the mole of vapor, it's very simple. Just substitute the desired parameters into the reciprocal formula, and we can get the value of mole vapor. And to find the mole of liquid, just 1 minus with the mole of vapor, and we can get the value of it. Then to find total flow rate for vapor and liquid, we just need to times with 100, and then we can get the value of it. And lastly, to check whether our answer is correct or not, just make sure that the total flow rate for vapor and liquids must be equal to the total flow rate of feed, which is 100.
So we move on to the process for the graph. So after the calculation, we can conclude that vapor stream and liquid stream, it is obtained for the two components, which is benzene and n-Hexane. So for the vapor stream outlet, mole fraction for the benzene is 0.5 0.462, while for the n-Hexane is 0.538. So for the liquid stream outlet, we obtain 0.54977 for the benzene, and then for the n-Hexane is 0.545023. Next, we move on to the equilibrium analysis, which is PSY diagram. Illustrate that the phase of behavior benzene and also n-Hexane system at a constant temperature, which is 75 Celsius. As you can see that the bubble point line, it is at a liquid region, while for the dew point curve, it is at the vapor region. And it's similarly to the TSY diagram, which is it is at a constant pressure, which is 103 kilopascal. This diagram also highlights that the pure component boiling point, which is at the 60 at 0.7 Celsius, it is for n-Hexane, while for the 80.1 Celsius for the benzene. Last but not least, this is all the list of references that we refer to guide our project. And I guess that's all from us. Thank you.